I think we'll see you very soon. Now it's visible. Go ahead.
Okay. So, hello, my name is Tarn, and I'm talking from Tallinn, Estonia. And I will give you a very quick, this 25 minutes max, a very quick look into what Thermory is, what thermally treated timber is, and what thermal treatment is, and what does it really do with the timber. So let's Thermory is we are 27 years old, and we consider ourselves the world's leading supplier, both in thermally treated timber as well as in sauna materials. We are in 6 legislations, both with production and sales organizations. We have 13 production units, 5 in Finland, 5 in Estonia, 3 in Latvia. We sell worldwide, 700 people, and this year we will be around 140 million euros turnover. We operate from 3 brands, Thermory for sauna materials, cladding, decking, exterior timber. Aurum is the brand who is doing ready-made saunas, both exterior and interior, and their main business is really adjusting day to day to clients' needs, our existing range, all the inquiries coming in with a little bit wider, a little bit longer. So this is their daily business. And Aurum has barrel saunas, but we will not cover them today. And then Sibarila is mainly for the Scandinavian market, or let's say mainly painted kiln dry cladding. So we consider ourselves specialists in exterior timber, cladding, decking, glued products, in interior timber, and in sauna products. And actually, as a category, sauna is much bigger than, let's say, interior design products. We on most of the markets, or in all the markets, we work with the resellers and distributors and architects, but in some markets we are very present to really get the first-hand feedback from developers and homeowners. So, but in all over the world, we are working with architects. And this is our presence. It's global presence with all its virtues as well as drawbacks. It's quite difficult to be compliant everywhere, but this is our experience. We are well certified, having the quality standards, having the eco-label standards, and we only source our raw materials from well-managed forest, have its certificates. And now in today's topic, to do thermally treated timber, then with all timber species, you cannot just go and buy the timber. It has to be from very special, specific region to be able to thermally modify it well. It's not with every timber species, but this is one aspect which will definitely show out in thermal treatment if the timber is sourced from the wrong areas. This is our materials, mainly what we do and what we sell. The top row is more to the interior of the saunas, and as I told that we make outdoor saunas as well. Then the lower row is more or less for exterior cladding. Well, some thermoradiata pine is used in exterior as well, and thermospruce is used in the sauna inside as well. But mainly, of course, the sauna timber is the left to the aspen, thermoaspen, and alder, and different shades of thermoalder. So, what is thermal modification? There is a European standard saying that for thermal modification, the timber cell structure has to alter, and for this there has to be at least 160 degrees without oxygen or in an oxygen deprived situation. So The normal kiln drying is not thermal treatment. This special treatment for the transportation, so to say, the heat treatment is not considered thermal treatment. And as well, let's say, what is popular in the Central Europe, the steaming treatment around the boiling temperature or slightly up. These are not thermal treatments. So what we say that we use only heat and steam, this is actually with a small caveat because we are using two different technologies, and in one of the technologies, pressure is another aspect working with the material or changing material as well. So it's, let's say, heat and steam and the pressure generated by the steam. And we have been doing thermal treatment now for 25 years. This is a very, very big approximation of one thermal treatment cycle, slow and gradual heating up the timber in order not to get cracking. Then the most critical phase, which really brings in the alteration in the cell structure. Here it's written from 190 to 215 degrees in this systems where the pressure is present. These numbers are slightly lower, but this is the critical phase, and then cooling down. And this 36 to 72 hours, well, it can be somewhat less, and it can be much more, or depending on the timber species, timber cross section, climate, the situation outdoors. So, but this is more or less an average cycle what we are seeing here. Just a quick look into our, well, the very first thermal kiln 25 years ago, as well as today our latest investment, 6 million euros into a thermal complex, and one and here is just a photo of one batch going into the oven around 30 cubic meters at one time. The process has to be very well monitored. The process is monitored automatically by the probes inside the timber. We take extra care to have the probes really under the right angle in the right places, and to have the airflow and circulation right inside the chamber. Nevertheless, who is doing, then there is things happen. Inside the chamber, the timber will start generating heat from inside out, and if something happens to the electrical system, or let's say so that the process is not easy, and the hard part of the process is up on this very critical level. So it's much easier just to make timber brown in an oven than to really achieve the right properties. So depending on the temperature, depending on the time, there is a change in color. Here we just bring out our main sauna timber, thermo aspen and thermo alder in the medium and in the intense range. So not only the temperature and the pressure and the time, this will all work and alter the material. Why we do it in the very broad terms, or why we do thermal treatment as a company, for hardwoods, we say that let's not use tropical timber. We can do it with normal moderate timber to give you the same durability, the same effect of grayness, much better other features. And let's say generally for the softwoods, we say that don't use chemicals. Let's not bring chemicals into this world. And even though the arsenics and copper, the very heavy chemicals, are banned in Europe, still with just this heat and steam, we can give the same effect. But there are many more, and let's look now into really what and why we do this. On top of every page you read why Thermory. Well, on one hand, I know about our material. On the other hand, yes, you can read it why like well and high quality thermally treated timber, because there is a lot of thermal treatment on the market. We have tested competition. We have not been very happy. So it was easy to write here why Thermory, but if it is a good producer, then you can substitute the word. The main point generally for thermal treatment, not really for the indoor sauna context that much, but generally is the biological durability. And this is the way how it is tested. The test is like 4 months. The controlled pieces are put into the environment with fungi, and the mass loss is measured, and hence whether the durability is gained or not gained. And it is much easier to make the timber just darkish, just brownish, and very often we can see that, or just looking into the material, we understand that it's good, so to say, for commercially to show out that the treatment has been made, but the actual biological durability has not been received. And one thing about the rightmost photo is what people have asked, that it is totally through the color change. There will be no light spot in the middle or nothing like that. But this is the main feature. And now coming already closer to the indoor sauna and clearly being in the outdoors, for many people, one of the main features of thermowood is much it doesn't cup, or it doesn't, but it cups, crowns, and twists much less than dry timber. It has half the swelling of dry timber in case of intensive thermal treatments, and in case of the medium, so to say, the color, the sauna treatments, it is around 60-65% of the swelling of a kiln-dried timber. But it is really straight, and for hardwoods, it is literally like you could almost leave the boards outside without any even fixing. They don't start twisting. In softwoods, they do, but still you can. All the people installing thermally treated cladding or decking, they understand how much kind of easier and more even the process is. Just the fact that they are much more straight and much less working allows for much finer detailization and much finer machining. And what this again brings, for example, we use a lot of joint end match milling, and the joint end match will save you 10-15% of the material on job site. It means you do not need to land the end joint on a joist. On the other hand, you can save a lot in installation speeds because we do a lot of this very fine negative angle milling for this particular clip system on the right. And on the center as well, having done things from timber, you understand why thermally treated timber is much better for these very fine machinings. So this is clearly a benefit from thermal treatment. Here is a view of a color change. On the left, it is the same timber species. The white one was the original with different regimes of thermal treatment. So it's the full palette, and not all of them have received the biological durability. And on the other hand, the right photo is that even when the color is closely the same, there is boards from two different technologies. Then the shine and the vividness of the original color change within the timber changes. So let's say that every thermotechnology influences the boards a little bit. Depending on the technology, there are small differences, and they might be big in commercial applications. So that's maybe the reason as well why we're running parallelly two different technologies. Paintability, well, it is on one hand complicated because we treat the timber specially to expel moisture, not to take in water. But there are other benefits. So if you know how to do it, then the paint will last long. And this is a growing trend. Painted thermocladding or thermo-treated boards, because of the straightness and the evenness of the end result, is a growing trend. Even though you would kind of not even need to do the paint, but we do a lot. And inside the sauna, we do a lot of pre-finished sauna boards, both for benches and for the walls, to have easier maintenance and some color. Light fastness of thermowood is fast. The effect on the left photos is around in 1 week. But in sauna context, we have never had any problems. It is maybe it has to be considered for the painted claddings and mainly delivering the product to the project batch by batch. There sometimes might be surprises, but they will be evened out in some weeks. So that yes, thermo-treated timber the light fastness is not only thanks to UV, but thanks to visible light as well. Gluability, just as paintability, the same question. We especially have made the board not to take in anything, and now we want it to take in glue, but we have more than 20 years of gluing experience, and the serviceability is pretty much like in kiln dried wood. So we have a lot of experience with the finger joint and lamella gluing both. So it is doable, but again, it's a little bit different from gluing kiln dried timber. Acidity, well, I'm not maybe sure. Maybe this is not a benefit, should not be said as a benefit. It is just a feature. Clearly, thermally treated wood, as the acidity is like 2 times lower. It drops to 4, from 4.5 to 5, as this is a logarithmic scale. So you need stainless steel fixings, and we always use stainless steel fixings. And normally the screw nail class A2 is suggested, or A4 for coastal regions. Now, just to mention that we have been using a lot of martensitic stainless steel, which is kind of stronger, somewhat stronger, a little bit can be magnetized. And all our test fields are done with that. And here you see one particular screw test with all different thermally treated timber species. And we have not had problems, but we cannot, you cannot take this right now as a suggestion, because any producer of the fixtures should say, can you use it or can you not use it with thermal treated timber? But one is clear, that stainless steel should be used. Just a small test that we have made, that it is generally not leaching. We have not had any problems. And here you can see how there is less color change from the washout of thermally treated ash compared to tropical timber or compared to oak. This has not been a problem, so it's not kind of colored brown. You do not need to be afraid of that. And now going to the very popular topics nowadays, the fire class questions. We have certified all our timber to Eurocode class D, which means comparable or equal to normal timber. Like 2 years ago, you could just take table values from the standard, but now change has been made that once you do any treatment, impregnation, thermal painting, whatsoever, you need to test. We have tested all our materials, they all comply to the timber class. And the second, the B, or the fire retardant, specially treated fire retardant class, is achievable as well with thermal-treated materials. So this is a big topic. It is maybe not even interesting enough. It is not so actively searched in sauna context, and rather, of course, in this high rise and big facades. But thermally treated timber, even though it is drier, therefore it's kind of easier to ignite because there is less moisture in. Nevertheless, it is class D, which means equal to normal timber, and if needed, it can be well impregnated or coated for fire resistance. Other mechanical benefits, or actually here we are really coming, the first point is the whole maybe reason behind this straightness and not fluctuation. It is that thanks to this thermal treatment, the equilibrium moisture content of the treated material is around half of that of kiln dry timber, which brings on half of the swelling due to moisture or ambient conditions. And in let's say the sauna, in the medium range, it is around like 65%. So it will swell much less because there is less moisture at any given moment inside the timber. The mass decreases for medium treatments around 2%, for intensive treatments up to 10%. This might be good for fire load calculations if the whole mass of timber inside the building is calculated, and therefore it might be of small help. The modulus of elasticity and surface strength, they are close to original. The mechanical strength decreases and brittleness appears, and it depends really depending on the temperature how much. Normally increase the calculations by 30% or use them well for the light constructions, but if needed really for load-bearing constructions, you need to test. So we have carried some tests. Some other values, there is no resin bleed normally in kiln dry timber. The heat transfer are smaller, which is good for barefoot, but and for sitting in the sauna, but not so good for underfloor heating. There is a change in smell, and this is one reason not every thermal technology is good for indoors materials. So we have changed in our production something because of that. But then again, if you even take just normal aspen and make a room from a normal aspen, you will even there find that the smell, what we all find pleasant, somebody will say, well, but it might be something now and there. Thermo is good for machining. It is much less demanding for under construction. It will not try to go away with it. And thermo is a good alternative conflict timber. One more, it's good for surface, different surface treatments. There is some use from the sauna or other things that can be used in the sauna as well. It's okay to press, it's okay to scratch, to do all these milling services. Thermo does not help against termites. Yes, the result is 2, 3, 5 times better than the control, but 5 times is not really enough if whether your sauna will be eaten either in 1 month or 5 months, you will not be happy. So it is does not give resistance. It has to be especially treated. And just that it's not easy to read about thermo from scientific papers because there is so many different technologies. There is the types, atmospheric, pressurized, or vacuum technology. Then there are technologies including some chemical impregnations. All the markets have their, and then there are all the regimes within the technologies and different timber species or the use cases. So whenever you really try to read about thermal treatment, you generally do not really get the answers you want. You need to test yourself. And so just one complexity. And maybe something about the EPDLCA context. The thermal treatment does not take much of energy. Like it takes only 10% of our company energy consumption because we rather have to cool the material inside the oven, not really heat it up there. So here are the EPD values, and it's not a big energy load, let's say. So some people have been afraid of that. Very quickly, just showing some as encouraging everybody to use short lengths, which is something that people from timber industry always ask you. In the saunas are small sizes. The end joint products, finger joint products, glued products, they are all working well in the saunas. We make additionally a lot of special products from the short lengths. And we use them in other interior and exterior applications. And this is pretty much all. I will have maybe just to show some 5, 6 other nice slides from the saunas made from our materials from inside and outside. This is all.
Beautiful stuff, Hannes. We have got quite a lot of questions lined up here already, so we could probably take a little bit audience input here if you don't mind.
Okay. And I was asked to write by the hosts where to buy from US and from UK. So I put this. But now, what do you suggest, that I go to the Q&A or?
Yeah, I will actually I will just pick the questions here for you. So thank you very much, Hannes, for this was a kind of excellent presentation, just kind of a introduction to the thermal modification I was looking for. So maybe we'll first start. You actually already kind of mentioned that there's like so the products are available both in the US and Canada as well, are they?
Yes. Yes.
Okay, so
Absolutely.
so this was good. How about France and Norway?
Absolutely, we are selling everywhere. You can always just write to the thermory.com and we will allocate you to the right people, to the right distributors or right people within our company who will come and visit you. So we are selling worldwide. We are available in Maldives and Japan as well.
Okay, so Norway and France shouldn't be a big problem for you then.
No. We are selling a lot. We're selling a lot in France. We're selling a lot.
Okay. Cool. I will take 2 other questions here as well. So one question is from David Kavanagh, is that is the process different for the thermal modified stuff that is supposed to go into a sauna, or do you use are the sauna products made with the identical process?
Tell me again, is the process different for sauna?
Yeah, or is there something special for the stuff that goes into a sauna?
Yes, there is something special. Let's say so that timber species dependent. For some timbers, we do not use the same technology as we would normally use for the sauna or for the indoors, because some technology leaves more of the residue of the not burning stuff inside the timber. The other technologies take more of it out. So for some timber species, it doesn't matter. You can use one technology or the other. For some other timber, I will not go into the specifics, but yes, there may be changes for the sauna, and we take them into account.
Okay. Good. I think that's settled that. Then I will next address a question. We'll take one more question before moving forward. Because a lot of the North American guests know very well that the red Western cedar has long been, or Western red cedar has long been the kind of most popular sauna wood. Have you had any experiments with this particular species? Would it be suitable for thermal modification? And if not, what do you think it's the kind of best comparison for someone who is moving away from Western red cedar towards thermally modified stuff?
I do not have experience with thermally modifying Western red cedar. And we are mainly selling our thermotreated aspen, which is close in looks, very close. I have been milling Western red cedar. It has been very soft under, I just remember it was kind of, yes, it is a nice and soft product. And actually, we have cedar in our product line, but we run very little. There is very little of cedar, but I think it is not Western red cedar. I think it was Siberian, and I do not know it right now because right now we do not buy since
Yeah.
we have a conflict here. Then
Situation.
we don't do nothing with the conflict timber. So I do not know about thermotreating Western red cedar myself, but we sell thermoaspen, and this is close to color, and this is the alternative, and good
Okay.
alternative.
Good. Maybe one final clarifying question. This comes from Kim Sanbu, and he was asking that do you make this kind of a charred wood treatment as well, the Japanese style?
We do. I had one slide, and this is we have a product series. We call the product series Ignite, and the product series is not achieved through charring, but what the way we say is that we have actually two times burned the timber. We press the pattern in. First, we take the thermal treatment where the timber would start burning, and secondly, we put it to the press with the temperatures much higher than the burning. So we say that yes, it is not the original char, but it is burnt twice, and it is much more durable for the whole process, for the transportation cycle and for the installation cycle and for the maintenance. So we have a product. It's called Ignite by Thermory. Take a look. I hope you like it. We sell it a lot.
Thank you. Great. Thank you, Hannes. I think this is time for us to give you a big hand. Thank you for coming. This excellent presentation.
Thank you.
Cool. And now we will move on with some more exciting stuff. And we move from Estonia to France. So from all places in Europe, one place you might not expect to find like a sauna engineer, but there he comes. So I have invited Corentin MacQueron. He has his own company, McQueron Engineering, and he will be talking about his pioneering work in modeling the Finnish sauna. Please go ahead.
Okay, so I will share my screen. I hope it's going to work.
Looking good.
Okay, so you see my screen, it's okay?
Exactly.
Okay, so today I'm going to introduce you to something called CSD, which is computational sauna dynamics. The idea is to propose sauna engineering into the digital era. So we are going to speak about the technical stuff now. So first, who am I? I'm Corentin MacQueron. I'm a French engineer. I have 18 years of experience in numerical simulation, in nuclear engineering and chemical engineering, and so on. And my sauna is my hobby. I started to mix my work on my hobby with simulations of sauna more than 10 years ago. I started my own company called MQE, McQueron Engineering, which is a company dedicated to numerical simulation for sauna engineering. I've been to saunas in Sweden, Denmark, Norway, Russia, Estonia, Kazakhstan. Sadly, not yet in Finland, but hopefully soon. I have built two saunas, one electric and one wood burning, and I have published a lot of stuff about sauna engineering, so you can check this out on my ResearchGate profile. And I am partnering with Saunologia from Lassila to do some sauna engineering. So what is exactly CSD? It stands for Computational Sauna Dynamics. It's an engineering approach that I propose. It is derived from CFD, which is Computational Fluid Dynamics. Fluid dynamics is used for aerospace, defense, nuclear, a lot of companies that do engineering where fluid dynamics is involved. You have to solve the equations that govern the fluid dynamics, and also heat transfer if you want to calculate how an airplane or how a car will run on the road. And what I propose to do is to translate this technology to sauna. So the idea is to make numerical simulation of sauna, just like we do for airplanes, car, rocket science, and everything. And here you have a little animation on the left about aircraft engineering with CFD, and on the right, what is the kind of stuff that we can simulate with computational sauna dynamics. So What's the difficulty? Well, the difficulty is huge because you have to solve all these awful equations that govern fluid dynamics, turbulence, heat transfer, conduction, convection, radiation in 3D and even in 4D, because you have 3 dimensions of space and 1 dimension for time. So it's transient 3D computation with full fluid dynamics that you have to solve. So yeah, it's no easy day. It's not easy. So you need some technical skills to do that. And solving a full sauna can take hours, days, or even weeks. So you better have a good computer if you want to do these simulations. So pretty much anyone can make a simulation about anything. If you want to have some fun, there are free and open source tools readily available all over the internet. So you can try for yourself to do some numerical simulation of sauna if you want. You will have results, but most of the time your results will be total garbage, and because you need to be a trained engineer in numerical simulation to have relevant results. It's easy to have results. It's very difficult to have relevant results, because if you want to do some serious stuff, some engineering, you have to prove that your numerical simulation provide results that are accurate compared to reality. So that is very difficult. And a sauna can seem easy, but in fact it's very difficult because you have combustion, Joule heating, conduction, buoyancy, forced convection, radiation, ventilation. You have leaks. You don't know what are your leaks. You have a stochastic arrangement of stones. So it is very difficult. And on top of that, almost no one can really know the physical properties of your materials. You know you have stones, you know you have wood, but you do not really know the thermal properties of your materials. There are a lot of uncertainties about that, so it's very difficult. And if you are to use some software of simulation like FDS that I use, you will see in the user guide that you are not supposed to do that, because unless you're a trained engineer in these in thermodynamics, fluid dynamics, heat transfer, combustion, and so on, you will have results, but that would be total garbage. So it's quite difficult. So the idea is what? The idea is to do what we call validation. Validation is to demonstrate that your simulation on a specific software with a given methodology, it works well. It works well enough to provide results accurate enough to be used for engineering. No model is perfect. All models are wrong. The idea is to have a useful model. What is a useful model? A useful model is a model that provides results that are close to reality, close enough so that you can use the model to then simulate any sauna, to make optimization and so on, to know what would be the good ventilation methodology, where you should put the benches, at which altitude, and so on. So the idea is to prove that we can do serious calculation. So my company, we underwent this process. We simulated various sauna experiments. So those are real sauna. We have experimental measurement of temperatures at different locations inside the sauna as a function of time. So we know what reality is, and we simulate those saunas, and we compare them. We compare simulation to reality, and we hope that they are going to be close enough. So, for instance, we simulated the VTT experiments that was done by Finland in more than 30 years ago. So it was like a scientific lab experiment with a very airtight sauna. So they had real scientific measurements, so like very accurate measurements with a typical closed-cased electric stove. So we simulated that. So here on the left, you can see the model in 3D. On the right, you can see some results, animated results. You can see the temperature of air in a slice in the middle of the stove or in the middle of the sauna. So you can see that it's nice, it's colorful, it's animated, so it's nice. But is it correct? So the answer is that it's not completely correct, but as you can see here, in blue, it is the simulation results, and in orange, it is the experimental measurement. And as you can see, for air temperatures and structure temperatures, like floor and ceiling, the curves do not match perfectly, but we have a very good agreement between simulation and experimentation. So here we can conclude that we are capable to do accurate enough simulation to make engineering for sauna. So here it is a temperature profile at different time. So you can see that simulation and experimentation are very close. So we can say that our simulation is validated. And a very important question in sauna is ventilation. Where should you put your ventilation? Should you have inlet above the stove or your inlet under the stove? And the same for the outlet. Where should it be? So in VTT experiments, they did a lot of different tests, and they concluded that as you probably already know, that you should have the air inlet above the stove and the air outlet under the stove, because you will have less stratification. You will have a better result, better comfort, and you can see that the simulation concludes the same thing. So if you don't do experiment but only simulation, if you follow this kind of simulation, you will have results accurate enough to have the good conclusion. So you can use simulation. As you can see, we have almost the same results. So you can use simulation to choose what should be your ventilation strategy. And this was for an electric stove. What about wood burning stove? So we modeled the Tampere University wood burning stove, and it was also a very scientific lab experiment. So with very accurate measurements, and with an RV stove, a wood burning stove. So here you can see the model and some results. Again, it's nice, it's full of color and it's funny, but is it correct? So here you can see that, it is not perfect, but we have very close agreement between temperature, simulated temperature and measured temperatures. Here on the left, you can see the flue temperature, which is the air temperature inside the stove, inside the chimney. So it's not perfect, but it's quite correct. And here it is the air temperature inside the sauna, and it's not perfect, but almost perfect. We have some discrepancy here. It's because they opened the door at this moment, so they let a lot of cold air enter the sauna, and it was not in the model. So of course it was not calculated here. And here you have a comparison for wall temperature, and again, it's not perfect, but it's very close. So, but those are very scientific lab experiment. What about home sauna that maybe you have a lot of leaks and you don't have so much accurate measurements? So here, this is my sauna in France. So it's a modest sauna with only 7 kilowatts, but I have a lot of stones, and I do not have a very scientific measurement system, just some home thermometers, and here you can see some beautiful results again with hot air going up. But again, is it correct? So here you can see that again I compare experiment to simulations, and as you can see, we are very close to reality. So again, even for a home sauna with a lot of leaks, maybe that we do not really know about, we can provide accurate simulation. So now we know that our approach with Fire Dynamics Simulator, which is the software that we are using, both for electric or wood burning sauna and both for closed and open mesh stove, we can provide results that are good to do some engineering. So we can simulate your sauna or any sauna, so to see maybe if there is something that we can optimize, maybe the location of inlet or outlet, or the amount of stones if you want to have a quick heating, or if you can wait a little more for the heating time. Anything is possible. So what can be done? Well, pretty much anything can be calculated. One of the most important thing often is the heating time. Will it take 1 hour, 2 hours, or 3 hours, or 30 minutes to reach the required temperature? You probably don't know exactly, but we can simulate it, and we just proved that we can be very accurate about the heating time. We can also check the stratification, which is a very important thing, because you don't want to have your cold feet on hot head. So we can try to calculate what could be the more comfortable stratification for your sauna. We can calculate the energy consumption. We can optimize the energy consumption, so you don't have to pay a lot of wood or a lot of electricity. We can calculate heat flux on walls, on people. So on walls, it can be interesting for fire risk mitigation. On heat flux on people, it's very important for comfort. Here you can see on this picture that if your legs are too close to the stove, you will maybe have some burn. So it's not it's not a burn, but it's not comfortable. So we can calculate all those things. We can even calculate Loilu steam cloud calculation in 3D in transient time. I will show you a few videos. It's completely doable. And of course, we can look for the optimal positioning for inlet and outlet. So here you can see some steam cloud simulation. You can see that we have the nice animated steam cloud, and you can see that the steam cloud does not go down. It goes up and it stays up. So most of the time, you want the people to be situated inside the Loily pocket. You want people to be in the upper part of the sauna. And with this kind of simulation, we can accurately calculate where will the steam cloud go. So you can be sure that your feet will not be cold if you make good simulation and then if you do the correct design of your sauna. So here you can also calculate, of course, wall temperature to check if something will not burn or anything. We can calculate heat transfer coefficient in 3D and the transient time. And of course, we can calculate the air temperature because it's one of the most important things. But we can also calculate all the radiation because in a sauna, hot air is good to heat people, but most of the energy comes from radiation and it is well accounted for in this kind of simulation. But FDS is not the only software that you can use for sauna simulation. There are other options because there are a lot of softwares around, but you need to have the skills to develop the models and to use this software. Otherwise, you will probably have a result, but it will be garbage. So there are commercial software such as ANSYS Fluent, based on the finite volumes method that I will show, or also Dassault from Dassault makes a software called PowerFlow, which is a lattice Boltzmann software. It can also be used for steady state or transient state 3D calculations, but 3D is not the only way either. You can also just do very simpler model like 0D or just 1D, not 3D. Sometimes 1D or 0D is enough. I also built an AI that can provide very fast results. So those models will be less accurate than 3D models, but they are much faster and of course much cheaper. And again, there are plenty of tools that you can use, but you need to have the skills to use them. So here are some pictures made with ANSYS Fluent simulation software. So this software is a commercial one, so you have to pay for it. It's very expensive, not like FDS, which is free, but it has the interest to be able to provide much more details, like you can have very detailed stones and very detailed geometry for the stove, which is not always possible with the previous software that I used. And here you have some results from PowerFlow. And those results are not mine. Those results comes from Daniele Esposito that I would like to thank. He's an engineer, a senior process engineer at Dassault, and he helped me to model the sauna with PowerFlow. And you can see very nice animation, very nice results. It's very accurate, like FDS, and you can have much more detailed geometry with PowerFlow than with FDS. But again, PowerFlow is a commercial code, so it will not be the same budget. But again, PowerFlow is a very powerful tool to do the sauna simulation. So in conclusion, sauna, of course, it's about tradition and culture, but it can also be seen, and it should be seen through an engineering perspective, because engineering and science can provide a lot of insight about sauna. And the idea is to use computational sauna dynamics built on modern scientific technologies to help to have new saunas, maybe more innovative, to have better comfort and better experience. So please do not hesitate to contact me or Saunologia to discover what we can do with simulation for your own sauna, if you are a professional, or maybe just your home sauna if you want to study some stuff. Here you can see some references that I used for this presentation. And now, please, if you have any questions, I'm here.
Thank you, Corentin. What an amazing presentation, and what an honor to have you here today. Because I think we were first in contact probably some like 7 or 8 years ago, or if not even further. And I know that you had a little bit of like a break from this sauna modeling business before you kind of took it up once more. And I think it's been just a pleasure to see what kind of things you've been up to in the past couple of years. And we do have quite a few questions from the audience here waiting. So I think I will, if I would do the honor and kind of, I'll be reading them through previously. So let's see where we'll begin. First of all, I would like to kind of start from this human factor because Steve Leppälä was asking that how much do you take into consideration the human factors? I think he's referring to the fact that most of the models seem to go without any people being inside the sauna. And how often do you kind of model actual humans as like a thermal objects or material objects or even like a breathing objects in the sauna?
Yes, it's a very good question. And people in a sauna will act as heat sink. They will not produce energy. They will remove energy from the sauna through perspiration. And as you can see in my presentation, sometimes in my simulation, people are in the model, so I can do it. It's totally doable. Of course, perspiration is hard to model, but in fact, we consider that people remain at 40 degrees because this is what we know from experimental measurements. A human being in a sauna can last for 15 to 20 minutes with a constant skin temperature of 40 degrees. So we create human beings in 3D in the model. We keep them constant at 40 degrees, and then we do the whole calculation. So heat flux from the sauna towards the people will be accounted for. And about perspiration, we can also release some steam cloud, which is in fact your perspiration that goes into the air. It's completely doable, and I've never done it, but I've been thinking about it. Maybe CO2 also that you exhale in the sauna could be produced injected into the model, so we can see if we have CO2 buildup or no. We can also optimize the ventilation, maybe not for heat transfer, but for comfort versus CO2. It's possible, yes.
That would be very exciting. And this was actually a question from Cosmin Kirik, so I think his question got now answered. There are a few other questions as well. I think maybe we would take that one. So I think Connor is asking. He was pointing out that one of the simulation studies you pointed out was your replication of the old VTT reference report regarding how you should set up the best ventilation for sauna. So what is your reading of the results that you also obtained in your simulation? Where should be where should we put the kind of air intake? Ceiling above the stone or wall behind and below the stove when we're using mechanical exhaust fan? Was it kind of clear response? What might be the kind of preferred? Where should the air come in?
It's a very interesting question. I think the answer is not general. It will be maybe case by case. From sauna to sauna, you can have different optimal location, but most of the time, if you can afford mechanical ventilation, the inlet should be in the upper part and the outlet should be in the lower part. Now, where exactly the ceiling, the inlet should be in the ceiling or in the hot plume of the stove, above the stove. But where exactly, it will depend. And also, what do you want? The idea is not to, if we optimize things, what is your idea of optimal sauna? What do you want? Do you want even temperature? Do you want even lowly? I think we should start from your requirements. What do you want to achieve exactly? And then we can try to optimize the location of inlet and outlet to target what is your idea of optimality, because some people will like to have even temperature, or maybe some people will be happy with some lower temperature in the lower part for children or so on. I don't know, but yes, the consensus, the best idea is to have inlet in the upper part and outlet in the lower part. But where exactly, it depends on the sauna, and it depends on your idea of what is optimality.
Okay, I'll put next one question of mine. I think Lisa Graves had her question now answered. I think I will ask one thing because you have been trying out with several different approaches and different software to do the simulations. In your opinion, do the different simulation approaches produce convergent results, or have you anyone discovered that certain products might produce different results? What is your kind of opinion on this side?
Results are always different because softwares are different and human beings that do the models are different. But I have done with Daniele Esposito, which is here in the audience. He did the simulation with power flow blindly, and I did the simulation with FDS blindly, and we don't have exactly the same result, but we have very convergent results, very close results. So the idea is that when the software is good and when the engineer is good, you have good results. So you can always have it's very easy to have bad results, but when the work is done seriously, you should have convergence between different softwares. So if you rely on serious people like Daniele or some other serious engineer, you will have convergent results.
Cool. So, so it seems that it's more important to have a person who really knows the tool that they are using rather than which tool you happen to get. And apparently, there are quite important differences between which solutions you pick because some of them might be very expensive to run.
Yeah. There are free tools, free softwares, and there are commercial tools. And of course, commercial tools are more expensive. Sometimes they are not that expensive, but still they are expensive. But most of the time, you are not going to buy a tool. You are going to buy a study. You are going to buy a technical report. So you don't have to buy the tool. If the tool costs 10,000 euros, you are not going to buy it. But if you buy a calculation, you just buy a study to a company that have the tools, they will not charge you 100,000 euros, of course. So you have to pick the correct tool, you have to pick the correct team, you have to pick the good engineer, and you should end up with a calculation that is never free because there is a lot of work involved in this simulation. So we can do it for free for marketing or for commercial offer, but usually nothing is free. There is no free lunch. You cannot eat for free. So you have to pay at the end. And yes, the cost will depend on the software, but most of the time you don't buy the software, you buy a study. So it will depend. But yes, it's going to be in a few thousand euros per computation.
Okay, I'll take one more audience question, and then I think we're going to have a short break before we begin our other part of the session. So here's a question from Peter Russell. He's asking that for a bathhouse entrepreneur, how would you recommend using the simulation? At what point of the property development process would you run this simulation? So I think
when the design is mostly frozen, when you should hire an architect or designer like you, Lassie, and you should have a good design. And when you think you have a good design that is, you follow the rules, the finished rules of Sauna. When you think your design is good enough, it is time, if you want to, and if you are willing to, if you have the money to, it is time to make a computation. And then if the computation just confirms that the design is good, then it's fine, it's okay. But maybe we will find some flaw or some way to optimize the design. And then we can modify the design, make another calculation to confirm or not that the new design modified is better. So you should not make a lot of computation and start with computation. You should start with good design.
Thanks, Corentin. I totally agree with that. And I think, in my opinion, I think the simulation can be mostly revealing in cases if you, for instance, planning to do a whole series of saunas and you kind of trying out something a little bit unusual. Which might, because we do have quite a lot of good best practices available, and I also documented in my books regarding how you do the basic sauna design, which usually kind of guarantees. So we've had here in Finland, we've been building almost 3 million saunas, and at least few of them are quite good even without computer simulations to support them. So you can kind of succeed without, but particularly if you're kind of exploring with new ideas, new type of heating solutions, then it might actually be quite valuable to reduce the risk in your sauna investment to use the simulation.
Yes, of course, you don't need simulation, otherwise we would not have sauna, but we have sauna. We have been having saunas for centuries and thousands of years, so we don't need simulation to have good sauna, but simulation can offer insight, especially like you said, when you have a maybe exotic design or very large sauna or very specific sauna, you are not sure of how it will behave, then it is time to simulate. But first you need to have a design as good as possible from the good old principles, from the Finnish standards. And if your sauna has nothing special, you really don't need a computation. But if your sauna is have something special in the design, or if you are a geek like me and you want to have a nice animation, you want to see how your sauna will behave with nice 3D animation, then it is time to make a computation.
Great answer. I think now it's time for us to thank Corentin for his time and his answers. I see there are still few ventilation relevant questions in the Q&A. So if you wish, you can Corentin maybe answer them on the chat. But I think we are now going to conclude this interactive session here on the video because we are going to have a short break. I have slightly adjusted our schedule, which it should be kind of reflected already in the lobby and in the following sessions. So we will continue in 12 minutes. What time it is depends on your time zone. Here are some kind of common time zones. So, but in 12 minutes, we will continue with the next part of partner presentations. And thanks everyone for coming. And I'll see you in the next session. I will soon close this session, but you can hang around here for a little while longer if you want to have chat with Corentin. But I will excuse myself for a little while, and we'll be back in 12 minutes, or I would be back. Corentin might still want to stay here. I'm going desperately to find my window. This I have to admit that I've had repeatedly being challenged by the Zoom system. But I'll be soon back. See you guys later, and girls and all other sauna fans.